Bismillahirrahmanirrahim. Chapter 10, Circles, and this is the second lesson, lines tangent to a circle. Our main objective is to identify lines that are tangent to a circle using angle measures. So this is first part of the lesson, and I'll explain this part of the objective with the help of the theorem given in the lesson. Then it says and the segment lengths, and the second part obviously we will solve the problems involving the tangent lines. So first of all, let's discuss some of the points or the vocabulary words. The first is point of tangency, and the second one is tangent to a circle. So let's define first of all what is a tangent. A tangent of a circle is a straight line that touches the circumference of the circle at only one point. Now clearly you can see we have two lines in this diagram. One of the line is this one, the green one, and one of the line is this blue one. If you look at the green line, it is called the secant line, and it touches the circle at 2 points, or you can say it crosses the circle or it touches the circumference of the circle at 2 points. But when you look at the blue line, this one, it touches the circle at only 1 point, or you can say it touches the circumference of the circle only at point T, and this point is called the point of tangency. So whenever you have a circle and there's a line that touches the circle at 1 point only, this point is called the point of tangency, and the line is called tangent to the circle. I think I made it very clear. Okay, now here is theorem number 1 of topic 10. It says if AB is tangent to circle C at P, then AB is perpendicular to CP. So if we look at the diagram and try to understand what is CP and what is AB. AB, as they have mentioned in the theorem, it is the tangent, right? Because it touches the circle at 1 point, and that point is P. Now what is CP? CP is actually the radius of the circle. So you can say that if you have a tangent line and the point of tangency is P and you draw the radius over there, then what is the relationship between this radius and the tangent line? They will always be perpendicular to each other. Perpendicular to each other means that you can say that this angle will always be 90 degrees and this side will also have the angle 90 degrees. So we can say AB, the tangent line, it is perpendicular to what? This is the symbol of the perpendicular. It is perpendicular to CP, the radius of the circle, and the measure of the angle will always be 90 degrees here. Now what is the converse? Obviously it is the opposite. They are saying AB is a tangent to the is perpendicular to the radius. So we already know that it is perpendicular to the radius. Then what will happen if they have this angle between these two lines, have the angle of 90 degrees between them, then the line AB will become tangent to the circle C. Clear? Now let's solve some problems related to this theorem. It says use this circle N and try to find that is MP tangent to the circle N, and you have to explain your answer. So what are they talking about? Actually they are talking about this MP, this line MP, and they are saying that is this line a tangent to the circle? Okay, it touches the circle at this point. Maybe most of you are thinking that yes, it is tangent to the circle, but before that we say it is tangent to the circle, we must check this angle, that what is the measure of this angle, because this is the angle that is between the radius and this line. So according to our theorem, if the radius and the line, they have the 90 degree angle, if they will become perpendicular to each other, only in that case this MP will be perpendicular to the tangent to the circle. Clear? MP can be tangent to the circle only if this angle becomes 90 degrees. How can we check this angle? Now look at the triangle that we have over here. Now what is the measure of this angle? It is 33. What is the measure of this angle? It is 58. In this triangle I can find the third angle. What is the name of the third angle? It is angle PMN, and this is the angle we are trying to find, PMN. How can we find it? Because 180 degrees is the sum of all the three angles of the triangle. So if you will subtract from it the sum of 58 and 33 and check what is the answer. Let's check the answer. As you can see, the angle is becoming 89 degrees. So this angle is 89 degrees. Now we cannot say MP is tangent to the circle. According to the theorem, if the angle between the radius and the line is 90 degrees, only in that case this line will be the tangent line. Let's see what do we have next. Now same, try it, but this is the P part. It says use circle N if LK is tangent to the circle N at L. What is KN? Now where is KN? Here is KN. Let me show you. Here is KN. They want to know how long is this KN. If LK, now where is LK? This is LK. This is tangent to the circle, right? And they want us to find how long will be this one, right? Let's see how can we solve it. Now if you look at this triangle, it's a right angle triangle. This triangle is a right angle triangle, and we can use the Pythagorean theorem for this right angle triangle. How much is this measure? How long is LN? Because LN is the radius of the circle, and here this line is also showing the radius of the circle. So if this one is 9, this one will also be 9. Right? Now according to the formula, it says C squared equals A squared plus B squared. I'm using the Pythagorean formula, right? Now let's put the values into it. C squared is this whole line, KN. Okay, so KN will be x minus 1 plus 9, because we have to add x minus 1 and we have to add 9 into it. So it will become x minus 9 plus x minus 1 plus 9 whole squared, because this is the hypotenuse. Okay, then the two short sides where we have the right angle, it says 9 squared plus x plus 5 squared, right? So this one will become, because minus 1 and plus 9, it will give us plus 8 whole squared equals 9 squared plus x plus 5 squared. Okay, now you have to remove this square. How do we remove the square? Once I told you in the class, you can say it will be x squared plus, now multiply all these three numbers together, it will become 16x plus, then square this 8, it will be 64. This is one way to do it. Let's say if someone does not know how I got this answer, she can write it twice, like x plus 8 times x plus 8, and then she can use the FOIL method to expand, and then she will get the same answer like this one. Okay, now here 9 squared is 81 plus, as I said, how I will remove this whole square, this complete square, it will be first I have to square this one, it will be x squared. Then I have to multiply this, this and this, so it will give me 5 times 2, 10x, and then I have to square this one, it will be 25. To solve or to get the value of x, I will move all the terms to the left hand side. So I will have x squared plus 16x plus 64. Now all these are positive terms, so on this side they will turn into negative terms. So we will have negative 81, negative x squared, negative 10x, negative 25 equals 0. X squared and x squared will cancel each other, and we are left with 16x minus 10x. It will give us 6x. Then we have 64 minus 81 minus 25. If you write all of this on the calculator, you will get minus 42 equals 0. And now how can we complete it? Let me complete this part over here. So we will have 6x equals 42, because we will move 42 to the other side, it will turn into positive. Now divide each side by 6, so we will have x equals 7. Is our question done? No. This is the first step of the lesson, because we are actually trying to find LK. Where is LK? This one is LK. Sorry, we are trying to find KN. So this whole line is KN. So how much is Kn? Kn is equal to x minus 1 plus 9, that is actually x plus 8. So it will be x plus 8. So put the value of x, it's 7. So 7 plus 8, it will be 15, right? Let's check the answer. Yes, it's correct. So this is our answer. Kn is equal to 15. Now pause the video here and look at all the steps very carefully. That do you understand each and every step? Let's solve the next theorem. Here is the next theorem. It says segment tangent to a circle theorem. Before I start reading this theorem, quickly let me explain you like what is this theorem about. For example, if you have a circle and we have a point outside the circle, doesn't matter, it's here, maybe it's here, here, anywhere it could be, right? If I draw two tangents from this point to the circle, so let's say this is the first tangent and let's say this is the other tangent. Now what will happen, you will get a point of tangency here. For example, if this point is, let's say, P, and this point is A and this point is B, then the distance from P to A and the distance from P to B, it will be the same distance. So it means that, for example, if this one is 10 centimeters, then this distance will also be 10 centimeter. So in simple words, we can say any point that is outside the circle, if you draw the tangents from that point to a circle, then the measurement of the line segment that is taking this, joining the point outside the circle to the point of tangency, it will have the same measurement. I hope I made my point clear. Okay, let's see. Now let's read the theorem. What does it say? It says if two segments with a common endpoint exterior to a circle, as I was saying, the point is outside the circle. So if you draw two segments from this point to a circle, so that these segments become or are the tangents to the circle, then the segments are congruent. So here they have taken a point exterior of the circle, that is point A, and they have drawn a segment to the point of tangency at B, and then they have drawn another segment to the point of tangency, that is C. So that's why AB is congruent to AC. This is the theorem, right? Now using this theorem, let's solve some of the questions. Here is the first right question. It says TX. So where is TX? It's this one. How long is it? It's 12. So we can write over here it's 12, and as they have mentioned this symbol and this symbol, so TY will also be 12, and also another way to understand it, because both are the radii of the circle. Clear? So this one will be 12 and this one will be 12. Now they said TZ is 20. Where is TZ? So this TZ, the red line, is 20. I'll make it with this one. So this is actually 20. So we can write over here this is 20. Now they want you to find how long is XZ. So how long is XZ and how long will be YZ. So first of all, XZ and YZ will have the same measurements, because according to this theorem, any point that is lying in the exterior of a circle or that is outside the circle, the segments drawn from that point to the tangency, point of tangency, will have the same measurement. Now how can we find this segment? So let's consider the triangle. First of all, XZT. XZT, it's a right angle triangle. As you can see here, they have mentioned it's a right angle triangle. So in this right angle triangle, 20 is the hypotenuse, 12 is the one of the leg of the right angle, and they want us to find the other leg of the right angle. So which theorem can help us? The Pythagorean theorem. So what is the Pythagorean theorem? It says c squared equals a squared plus b squared. So let's substitute the values into it. C squared is actually the hypotenuse where my pen is moving right now. So it's 20 squared equals a squared is one of the legs. So it's 12 squared plus b squared. Now you can move this 12 squared to the other side. So you will have 20 squared minus 12 squared equals b squared. Let's put it on the calculator and see what will you get. So it's 20 squared minus 12 squared, and it is giving us 256. So it's 256 equals b squared. Now we have to get rid of the square, so we can take the square root of each side. So it will give us b equals 16. So this is the possible value of b, or actually b is the other leg of the right angle of this right angle, right? So this shows that xz is equal to 16. So how much will be yz? It will have the same length, that will be 16. You can call it units. So both the measurements will be 16 units. Is that clear? Here is the next question. It says, now because we are done with the triad question, so let's solve the questions from the lesson. It says the segment AB and CD are tangent to the circle T. Find each value. So we have different questions to solve. So number 16, it says find how long is AB. So this is the line AB. As I told you, whenever you have a radius and a tangent, they will be perpendicular to each other. So ABT is a right angle triangle. So if I'm trying to find this length AB, I can make use of the Pythagorean theorem as I did here. So you can see that in this diagram, AT is the hypotenuse, so you can call it C. BT is one of the leg of the right angle, so you can call it A. So let's say this is A, this is C, and we are trying to find B, right? Okay, now how long will be AT? Can any one of you guess how long will be AT? It will be 12. Why it is going to be 12? Because you can see here that this part of the line is 6 and this part of the line will also be 6. So together all of it, AT will be 12 units, and we have BT, that is 6 units, and we are trying to find AB, right? Now AB is one of the legs, so if I represent it with the letter small b and I represent this with the letter small a, and this is the hypotenuse, I represent it with the letter c, so it is going to be c squared equals a squared plus b squared, right? So c is 12, so it's going to be 12 squared equals 6 squared plus b squared. Now you can move the 6 squared to the other side, so it's going to be 12 squared minus 6 squared equals b squared. By the way, you can solve it right now, or directly you can say take the square root of each side, so it will give us the answer. That will be b equals, let's check what is the answer. So you can write like this on the calculator, 12 square root of 12 squared minus 6 squared, so it's becoming 6 square root 3. Okay, now it will depend on the multiple choices, that have they given you the answer like this. So there's a possibility if they kept the answer in the third form, you will leave it like this. But if the multiple choices have the answer in the decimal form, then it will be, let's say, 10.39. So I'll write over here b equals 10.39. So it can be given in any of the way, right? Okay, let's solve next questions. Now question number 17, it says find the value of angle TDS. Where is angle TDS? So let me make it for you. This is point T, and this is point D, and this is point C. So they want us to find this angle TDC, right? Or you can say, in simple words, you can say they want us to find angle D. Now to get the value of angle D, we have this angle. It's given 8x plus 2, and this angle is given 4x plus 4. As you know that this angle will be always a right angle triangle. Now quickly I want to tell you something. Now some students, they write the equation like this, because first of all you have to get the value of x, right? They write the equation like this. They said 8x plus 2 plus 4x plus 4 will be and plus 90. They say plus 90 will be equal to 180. 100% correct. Like if we add all these three angles, their sum will be 180. But I will tell you another thing, that whenever you have a right angle triangle, you can do it in this way. I'm not saying it's wrong, it's all correct, right? But there's another way to understand the question. Like whenever you have a right angle triangle, we know that this angle is a right angle. So what is the sum of the other two acute angles? So 8x plus 2 plus 4x plus 4, it will always be 90 degrees only. And even you can see from here, if I move this 90 to the other side, it will be 90 minus 90 on the other side. So you will have 90 on this right hand side. So it's all your choice. You can write the equation like this, or you can write the equation like this, the way you understand it. Clear? I'll go with that one. So let's solve it. So it says, as I was saying, it's going to be the two acute angles. So 8x plus 2 is the first acute angle. If you add both the acute angles of the right triangle, its sum will always be, or their sum will always be 90 degrees. Now 8x and 4x, it will give us 12x, and 2 plus 4 will give us 6 equals 90. Now let's move 6 to the other side. So it's going to be minus 6. So it is 84. Now divide each side by 12. So it will give us x equals 7. Is our question done? No, because we are trying to find this angle D measurement. Angle TDC is actually given 4x plus 4, and we are supposed to substitute the value of x into it. So it's going to be 7 times 4, 28. 28 plus 4 will be 32 degrees. So this will be the value for this angle. Pause the video here and try to understand each and every step. Very simple question. I want you to pause the video here and solve this question on your own, and then play the video to check your answer. Here are all the steps explained. So we know that this line segment ED and EF will be equal to each other. So we can say 2x minus 4 is equal to x plus 7, because the two segments are equal. So we can get the value of x from this equation. Move the x terms to one side and the constant terms to the other side, and we are getting the value of x equals 11. Now the next step is this one, because they want us to find how long is DG. DG is the radius of the circle, same as GF is the radius of the circle. So we can say DG is equal to GF, and it is actually x minus 2. Substitute the value of x, that is 11. So 11 minus 2 will be 9. Is that clear? Here is another very easy question. They want us to find the perimeter of this quadrilateral JLNQ. Where is JLNQ? Let me show you. This is J, so you have to find how long is JL, and then how long is this one, how long is this one, and how long is this one. You have to make use of one of the theorem in which it says if any point is lying outside the circle, and then you draw two tangents from there, then the line segments that are joining the point with the point of tangency, the measurement will be the same. Just I will explain you one of it, and the rest I want you to complete on your own and check your answer. Then look at this. If I take point J, this is the circle, right? So if I draw a tangent from here to point K, and if I draw another tangent to the circle, and the point of tangency is R, so J to K is 3, so J to R will also be 3. Following the same rule, following the same theorem, complete all the measurements and then get the perimeter, and perimeter is to add all the sides. Here is the answer for this question. You can check that this one is 3, so this point will be, this measurement will be 3. If this one is 5, the other side of the segment will also be 5. Here 2 and 2, and then 7 and 7. So when you add all these numbers together, it will give you the perimeter of this quadrilateral, that is 34. Clear? Here is the next question. It says find how long is AC. Where is AC? AC is this line from here to here, right? Okay, now if this part is 29 from E to F, so A to B will also be 29, right? Okay, if this measurement G to E is 9, so G to D will be 9 and G to B will also be 9, right? Now look at the right triangle. This is the right triangle. Why this is the right triangle? Because this is the tangent and this is the radius of the circle. So tangent and the radius of the circle will be perpendicular to each other. So following the question that I explained before, this is the hypotenuse of this right angle triangle. This is one of the leg of the right angle triangle. Find this one. How long will be BC? Why we are completing only this triangle? Because we know that this AB is 29. If I will be able to find how long is BC, it will, if I will add 29 with that number, it will give me the total length of AC. Now you have to make use of the Pythagorean theorem. Better pause the video here, find the measurement of BC, add both the measurements and to get the length AC. Clear? Here is the answer for this question. This measurement, this whole length AC is becoming 69 because I added 29, and 40 because BC is becoming 40. How I got 40? You can check from here. How long is this GC? It's 41. So according to the Pythagorean theorem, this is the hypotenuse, so 41 squared will be equal to 9 squared plus BC squared, and the rest of the steps are very simple. We have done them in many questions. So let's see, what do we have next? Okay, here is the next question. It says line M is tangent to circle A at B. What is the area of the triangle ABC? Now as you know that it's a right angle triangle always. Here we have the right angle. If you want to find the area of the triangle, so the formula for finding the area of the triangle, it will be half of base times height, right? Now if you take this is the height of the, so it will be 4. How long will be BC? We have done many questions like this in which you have to make use of the Pythagorean theorem to get the value of BC. Pause the video here and complete this question on your own. So here is the answer for this question. I found this, first of all, this measurement BC using the Pythagorean theorem. So one very important thing, girls, most of the girls, they cannot understand that why do we take this one as the hypotenuse. So this is the hypotenuse because it is opposite to the right angle, and this is the longest side of the right angle triangle, and its measurement will always be the sum of the measurement that is given outside the circle plus this radius. So together this whole line will be 4 plus 5, 9. So hypotenuse is 9 squared, then we have 4 squared, one of the leg of the right angle triangle, and BC is the other leg of the right angle. So this one will also be 4 because this is the radius of the circle. Now the formula says area of the triangle is equal to half of base times height. Now one of the leg is the height and one of the leg is the base. So height is 4 and base BC, we just found that it is square root 65. I just substituted the value into the formula and I got 2 square root 65, and this will be the correct option. Clear? Here is another challenge question for you. Better pause the video here, try to solve it on your own, and then play the video to check your answer. Here is the answer. It's C, the correct option. It's B. Now clearly you can see that this radius is 5, this radius is 5, and we are trying to find how long is BS. I again make use of the Pythagorean theorem. Now because we have done it many times, the same Pythagorean theorem, so I used it directly. Whenever we are trying to find one of the leg of the right triangle, so we can say the leg square will be equal to hypotenuse square minus the other leg square, right? So it is giving a square root of 56, and if you, when you put it on the calculator, it will give you 2 square root 14. Then to get the perimeter, I need to add all these yellow lines because they want us to find the perimeter of the quadrilateral PQRST. So when you add all of them, your answer will be 10 plus 4 square root 14. That is option B. Hope you understand the lesson. That's all.